Good afternoon and welcome to today's Astadia webinar featuring You Can't Ignore DevOps Any Longer. Let's get started. John, I'll hand it over to you.
Thank you, Desiree. Everyone, my name is John D'Antino. I'm the VP of Marketing and Business Development here at Astadia. Just want to get started with just a quick couple slides about Astadia in case you're not familiar with who we are, and then I'll turn it over to Will Hurley, who will take us through the webinar discussion on DevOps. So Astadia is a premier technology consultancy focused on maximizing the impact and minimizing the risk of today's blended enterprise and cloud ecosystem. Our clients choose Astadia for our experience, agility, and the results we deliver. Those results are delivered in four major focus areas, as you see on the screen here, around cloud migrations, moving enterprise workloads to target cloud environments, typically AWS or Azure. Cloud development, and you'll be hearing from the head of that group today, Will Hurley, to design, build, test, secure, and deliver great software. Managed services, where we deliver 7x24 visibility and support for the blended IT ecosystem we were discussing. And legacy modernization, where we assess, identify, and modernize mainframe-based applications and databases, whether we reuse, rewrite, or replace those applications. So without much more than that, let me go ahead and introduce you to Will Hurley. Will is our AVP of Software Lifecycle Services, which is responsible for our cloud development offerings as well. I'll let Will get into his background a little bit and cover not only where he's worked, but also some of the consulting projects he's been on. Will, I'll turn it over to you.
Thank you, John. Thank you for the kind introduction. Again, I'm Will Hurley. I wanted to share a little bit of my history so you have a good idea where I'm coming from. The chart above shows when I was employed, and the rest of the time, as my family says, you know, Dad, what do you do? What's a consultant? So back originally when I graduated, I worked for the Air Force on a AWACS. And so we upgraded AWACS a couple times, all hardware. You know, the motto of the group was delivering yesterday's technology tomorrow. And it's one of the reasons I got onto the software side and theater battle management, where we were integrating theater systems for all the service branches. It taught me a lot about understanding how to integrate projects, issues with data, security, and dealing with devices. And so in my consulting life, it sort of followed that I've supported all those initiatives over time. Early on with financial services, later in my career with devices, big data, and security. And it's one of the things when I left Cisco, I thought you know, I wouldn't continue on the security side, but it seems to drag me back as there are a number of issues. Today's discussion, though, is focused on DevOps practices, why they're important to your organization, and it provides some insights that we've developed again, all the way back to the days of in Cognex when we were trying to deliver fully automated releases of vision software. So as the agenda states, we're going to try and define DevOps. There's lots of information out there, lots of opinions. We'll take a look at some of the thought leaders and sort of give our own definition. Why is it important for your organization to adopt? And what I call sort of the best practices. We like to call it good or necessary practices. The techniques we use for adoptions, some takeaways, and then questions and answers for the group. Anybody who has questions can push them to Desiree. And certainly during this presentation, just type in your questions. So again, what's DevOps? So Twitter is has a great hashtag, DevOps influencers. There are tons of the people who are visionaries and practitioners. The one person I'll pull out here is Gene Kim, K-I-M, who basically wrote, I'm not sure if anybody has read the book, but back in 2013, he wrote a very exciting novel called The Phoenix Project, and that was about a fictitious company that was implementing practices to save the job of their CEO. That goes through a lot of the actual mechanics of what's done. If we take a little closer look, and I said I sort of did the theme for you, but Jess Humble and David Farley came out with a fairly recent book called Continuous Delivery. And so both Kim, Dave Farley, Jess Humble, they're certainly well known. I suggest you take a look at those books. It will help you out. But the common themes to all these things, they certainly touch on culture, collaboration, measurement, responsibility, transparency or visibility of the actual process. So these are, these are important to most things that we do in terms of producing something. If you think about, building a car or an aircraft, or, putting anything together, and certainly software right now can be viewed as a system of systems that needs the ability for those people contributing to its success to understand where they are in the process, how well their processes are actually working, and having the confidence and culture to collaborate and make changes to increase value for the business. So for our definition, it's split into two, and because there's a business alignment or component. So for the business, the key purpose of DevOps is basically being able to reduce the time from the idea to the delivery of working software. And again, the whole notion of collaboration, measurement, and governance from the business perspective is important. And that development piece, it's really the investment of the organization. It's not creating value, it's not creating any brand value while you're actually building it. So it's an investment. When it's finally delivered, when it's finally operational, then you create brand value or reduce brand value based on the quality of the work that's delivered. But as you see, there are two sort of revolving practices that need to feed back. Now, a lot of people will show this as an infinite loop, but the reality is through regulation and business culture, organizational structures, it's really at the highest level you can think of it as two independent loops that need to be connected. And the other piece, if you go into much more detail on this, you could drive down and say, hey, we have a QA organization, and that could become another loop in transformation. Or we have a specific security organization, and that can become another loop. So it can become obviously very complex. From a business perspective, this is sort of the simplest slide to show the notion of idea to brand value. We then have the technology alignment, and really from a technology perspective, I'll use the term pipelines, but we're trying to deliver things reliably and repeatedly, and pipeline's sort of a common term. And again, the techniques we're using, collaboration, automation, and measurement, because this is when the work is actually done. The diagram to the left is a view of a pipeline that's a demo pipeline in Jenkins, their Blue Ocean product. I attached a URL down there so you guys can investigate yourself. But it's really a series of those necessary steps to basically move or reliably deliver working applications into a known environment. And so this is a real simple one, just to get it on the slide with my actual words. But the notion is, there's a build step. There are testing steps that can be divided into how you're actually testing or what frameworks you're actually using. And you can see the JUnit or DB unit tests being run. Then there are UI type tests against the browsers, and in this one it's showing a Firefox, Microsoft, Safari, the common sort of common presentation platforms. And then those things are actually pushed to dev, where artifacts may be stored or consumed by other developers. It gets pushed to staging and production. So there are a number of excuse me, there are a number of other steps happening in each of those locations, but the whole idea is that you can document those necessary steps and provide enough detail in each one of those steps where you can drive reliability. The whole idea there is, when I say what does a pipeline really demonstrate, well, it demonstrates automation. Humans aren't great at being able to reproduce actions, and especially, and I know we all see it as software goes into different environments, whether it's a QA stage or production, there's usually a large number of manual steps. You find out in some cases where it's your software is not regularly built, that what's delivered it doesn't work in staging, doesn't work in production. That can be from differences in practices used. So again, this is a good example of showing event visibility. It's all green, the checks that you're seeing, but what happens is this blue ocean front end will actually turn the green check circles into red if something doesn't occur, if the event doesn't occur properly. So again, the reason you guys here are why adopt, how do you convince business, how do you talk to other people about why DevOps is important. And you see my DevOps operator on the side. He's built his pipeline as well. But the whole idea here is to reduce the levels of unplanned work and downtime. So that's reducing rework. It's understanding that there are lag times in various processes, technical debt that's being carried and not addressed, and this happens a lot on agile projects. In fact, the two things that I'll talk about real quickly is the process lag time. So we have clients that say, hey, our security team, we have to hit certain blackout dates and have a quarterly release schedule, and they start mapping out all the events that need to occur, and then they say our security team needs 6 weeks to do this, our QA team needs 4 weeks, or it required 8 and we got it down to 6 weeks, which was a great improvement. But really those time periods are all about the process lag, and from a business perspective, why do you have to wait that long? And it's usually, again, although you're using agile practices in some areas, other pieces of the organization might not be agile, they might not be talking, it might be stovepiped and sort of it's business as usual, and that's really the opportunities that DevOps provide across the organization to improve sort of that delivery throughput. I ask everybody to think about, how much is unplanned work costing your organization? And unplanned work goes from everything such as, all developers build and test on their own machines, testers testing large data sets, build and test on their own machines. A lot of these things can be improved with the technologies that we have today by moving testing off the individual machines and having build servers, those types of things. It's not necessarily all in, it's progressively getting better. But if you can't answer that question, how much unplanned work is costing your organization, that's something that you actually get. More mature DevOps organizations understand that. How much downtime is this costing your organization? That's another thing that can be delivered as a measure or metric of goodness in terms of how well the IT organization is performing. These things are very difficult to actually pull out, but it happens to most organizations in terms of downtimes based on a bad release, and even the biggest organizations and some that do practice DevOps, they still run into these issues. But the reality is, those people that have adopted DevOps culture basically are using the correct scope and practices that enable sort of that successful, sustainable delivery operation. They experience a lot less than companies that don't, and these are really the reasons that you really need to understand invest and sort of culturally commit to these practices. Next set of slides are going to cover how we organize stuff. You see a lot of continuous stuff. Configuration management sort of is the one key that rules them all, and then around everything is culture. And the whole idea, culture eats DevOps for breakfast. The whole statement is operational excellence for lunch and everything else for dinner. I think it was attributed to Deming, but I'm not sure if he actually said it. But really, what is culture? It's a pattern of behaviors, which means they're learned, they can be unlearned, they can be influenced by other people, and this is really where a lot of the current DevOps culture comes. It comes internally, but what happens is it's implemented for a particular project, and sometimes the implementations are their initial implementations where they never consider security, they never consider a lot of the functional and non-functional requirements that the organization has to deal with, so there can be limited benefits. Another big piece on this thing in terms of culture is tools are not culture. Tools are the mechanisms that we use to do things, but from a configuration management perspective, a lot of people have source code control management tools. They may fight over which ones they like or dislike, but culturally it's, do they check things in often? Do they test when they check things in? Those are the cultural things that, even though you can actually have the tool, the culture prevents you from executing with an optimal capability. And we see this all the time where people might bring in a build master, right? So we like build masters, we think they're good, but they can hide or allow cultural problems to continue. And one of those things is like having the build master run around and ask why a build is broken, or who broke the build, or go back to a developer and say, hey, you broke the build, you have to fix it. That's a cultural thing, and it's not a thing that a build master should be responsible for. It's sort of like herding the cats, but that's why culture sort of wins in the end. It has to be part and parcel with the implementation of development and operational changes. So jump into the next one. So I'm going to go through each one of these, sort of give you, again, sort of the talking points, the ideas on how things can be viewed. We use these 5 items: configuration management, continuous integration, continuous testing, monitoring, and delivery, all as mechanisms to control how we get people, teams together to sort of build out common vocabularies that then can be executed in architectures, or basically placed and evaluated in an architecture and then executed as part of a deployment. But so configuration management is really your ability to create an exact reproduction of configurations and environments. And when people say, well, what do you actually put in your source control? And configuration management can be viewed as a couple different things. The primary thing for software projects is your source control tools. So whether it's Subversion, AccuRev, pick your poison, Git, whatever, GitLab, everything that's in code or documentation about steps and practices used in DevOps should be in version control, and that's really the one way that you're able to reproduce a lot of stuff. And it's the interesting thing. It's from a delivery practice, deliver into operations. You're not pulling this stuff out of source control. It's really to understand and allow the development and test teams to marry releases with what needs to be validated. And there are other tools out there like the Artifactories, Relics. There are other tools out there to actually manage the actual artifacts that are built. So again, you'll need to assess your configuration management maturity, and how quickly can you recreate a named environment from scratch? Can you do it? It becomes really quite difficult. This is what we found with most clients, because they don't have everything in version control that they need. And it really becomes even a bigger issue as we move to continuous delivery practices and being able to stand up cloud environments that configuration as code. So this is a key point, and it's why we layer configuration over all the continuous processes. A couple other questions down there that are also interesting. When I say ask yourself, are all the assets that you actually need in version control? Because after you release a product, it's not just the label. The label doesn't necessarily give you the ability to recreate everything that was actually done. And then how well do you think you manage your components and their dependencies? This is another big thing. And it really comes down to as you go on your DevOps journey, as you become more effective with it, then you need the capabilities to disengage having to release multiple projects together based on dependency. So this is, again, another important issue in terms of your journey and becoming mature. The big thing about continuous integration, so this is really the build, how you build, who owns that build, who fixes it, and the key thing here is fail early and fail small. So simple branching techniques, frequent builds, using building off the developer's machine, taking the results from an actual build server. That's really where it's at to drive the ability to build and test whenever change occurs. Culturally, if it's the notion, and I was mentioning this before, hey, if you broke it, you fix it. And that means that if you're building on build servers or building off a developer machine, then they actually have to have visibility. They have to be able to see these things. Having good release notes in a tool like Jira becomes really important because it supports collaboration. What are people going to be responsible for testing? Well, they can look at the change notes and make more appropriate changes when they're doing their testing. And it also goes back to a lot of us, a lot of developers, they have, very good integrated development environments. Everything actually happens in their IDE. Maybe cloud-based, maybe on their machine, but the reality is that everything needs to be able to build up off the command line interface, and that's how you actually get to continuous integration, as well as their continuous integrations servers, Jenkins is one, which is run by CloudBees, Travis, Bamboo, Team Foundation server for Microsoft, and Team City for JetBrains. So there are lots of tools, but as I said, it's really not a tool issue. It's a understanding what your needs are and then selecting the tool based on your requirements for continuous integration. But it does only cover sort of the check-in, check-out, which is the branch merge strategy, building, and then verifying that that build was tested and is okay to be merged back into your main line. Continuous testing, so this is the old shift left. Anything that you can do earlier, do it earlier. And it's funny, it's sort of the first statement up there, it's a play on words, but really is eliminating the technical deficits before they become the features in your releases, and then being able to test the business features before they become the defects in your releases. So there are two components here. Continuous testing happens early and often in any of the development cycles that we actually use that we were showing, whether it's DevOps, whether it's DevOps or whether it's development. There's testing going on, whether it's unit type testing, integration, API testing, system level testing, UI testing, security type testing. All these things can be integrated and need to be integrated and evaluated when you're looking at continuous integration testing. It doesn't mean that they all have to be available, but you have to take the concerns and requirements from the entire group. Again, DevOps is about communication and collaboration. So if you don't involve these people, then you're going to have solutions that are not complete. Other things about continuous testing is how do you make it faster. Simulation and virtualization, so a lot of developers have the ability to simulate particular products or platforms, and then virtualization is another technique where they're able to actually use interfaces or systems that may be too expensive to implement in a testing environment, so they can record production results and then basically play them back to support testing. Performance testing is one I left out, and the infamous but never to go away manual testing. You need end users, you need testing professionals to look at stuff. It's sort of like, you know, why professional writers have editors. It's always good to have another set of eyes on it. It can't slow down the release, so it needs to be planned appropriately, and there needs to be enough communication that they're doing the right manual tests. The fourth item here, or what we would call of the tenets of DevOps, is continuous monitoring. So good measurement is good management. That's an old term. We like to say, you know, you can start out with sort of the short circle, but if you're not using measures, then lose them. Don't carry them. Don't, you know, there are no sacred cow measures. We do believe that there are, from a DevOps perspective and how valuable your practices are, there's some basics that should be covered, and that's time to feature delivery. So if there's again, having the capability to identify the time, the start time where the request was made from the business to the feature delivery time, and that's really, you know, that's sort of one of the seminal measures of understanding how well you're adopting and how well DevOps are actually supporting your business needs. Downtimes and change rates are other things. There are a number of tools that allow you to capture this information and use it. The whole idea of a single pane of glass. So that's, you know, in some cases Jenkins can actually be used. In other cases, there are a number of open source as well as commercial tools that give you that monitoring view. And the importance of this, of development not having access to production, but having access to data about, or I won't say the data, having the data processed so it provides developers information about the performance of their last release, customer satisfaction. Those live types of measures become the automated feedback loop that sort of drive you to get closer and closer to that infinite loop of being able to, you know, connect development tasks with operational tasks. And again, if you can identify those requirements and those are your requirements, then there are a number of tools out there that can satisfy. Like I said, it's the whole idea of using these categories to establish sort of that the vocabulary that you need to communicate between groups so you can establish outcomes, and then use architecture and diagrams to build those architectures to fulfill the needs of each person. And the last pieces of the tenets are continuous delivery. So, you know, the overall delivery or model is basically managing both the performance and conformance. So it has a dual view. It has the build view in terms of how the application is performing, and it has information about conformance to regulatory requirements and capabilities related to sort of non-functional performance issues. Key thing here is that these are repeatable practices that need to be implemented and automated for each environment that you're actually delivering to. Think of it as deployment is a feature of your overall organization, and it has to be understood. It's a very important piece of this, and obviously it's one half of the DevOps name. The ability to reliably provide changes and obviously deliver compliant business features faster and get them delivered when required. I say automation because a lot of this stuff you really have to rely on eliminating the variation that we create right now, especially in organizations that have quarterly release schedules. It's hard to understand or document all the mechanics. You know, a Word document is not a great tool for a person to use every quarter to try to get you know, the software running on a particularly complex system of systems. So this drives the need for automation. The other big thing is, you know, the same practices. Code as infrastructure, as I mentioned before, those types of YAML files can be captured, and so you actually have a lot of the same activities occurring in an automated fashion. Parameters may change, or some of the variables may change, but that's really what the human can actually manage. And even incrementing DLLs or identifying that services were started or available or restarted if not available, those types of checks and balances should be in your deployment practices. The whole idea, obviously, with a lot of these things is to discover and correct problems before they release and basically reduce business value or brand value. So that's sort of the overall view of how we organize the world. And the next thing we're going to jump into adoption, some of the techniques that Astadia uses, has used over a number of years. As I said, it's DevOps is not a new approach or techniques. Certainly some of the tools and commercial organizations have taken it to a new level. But again, it really comes back to collaboration, understanding how to pilot adoption, and in the end reducing or taking the opportunities to reduce sort of the human piece, the interaction where errors can occur. From the collaboration perspective, you know, as we say, it's architecture. It's do the paper architecture before selecting the product or the vendor. There are lots of tools out there. One of the things that we see is we see people implement, let's say like a Jenkins, and they'll say, oh, geez, you know, we use Jenkins. We didn't really like Jenkins. We're using Travis now. And the interesting thing is the tools are doing the same things. It's really approaches that people are using that are different. And if you look at typical organizations, development teams are out there and they may be selecting their own tool sets. So what you find is a lot of redundancy, which doesn't allow people to necessarily move between environments with a good understanding of the continuous integration or testing or integration practices. And these may be commercial tools. So you'll see people, you know, I've had people say, hey, I say, what do you use for software configuration management? And they'll say, well, we use Visual Studio or something like that. They'll confuse the IDE, which certainly can connect to Team Foundation server or some other type of Git server to provide a service, but the vocabulary, no one fully understands the vocabulary within the organization, and people are making a lot of decisions themselves to support their organization. A lot of times what you find are tools are misconfigured. They don't have the correct security settings, which is one of the reasons that engineering platforms on the web or in the cloud are becoming very interesting to people, because they can go and actually sort of select so a mature DevOps environment that's properly configured for them. Other things about collaboration, as I said, are having meetups internally and training. You can't leave training out of the mix. People are interested in this stuff right now. It's valuable for their careers. It's valuable to the companies. So we always suggest companies support meetups and trainings for DevOps, and the need for specialists to ensure sort of the correctness of those initial configurations. As I said, we see a lot of times where you ask if someone does DevOps in a project and they say, yes, we have a continuous integration server. And then you go and look at it and you see that, it was supposed to be integrated with another quality tool like a Sonar, and you find out that the integration was never completed and the reports aren't being generated. So it really comes down to that there were good intentions and the thought process was there, and they may be using some of the features, but a lot of times, the project is what we call in flight. It's already going, and they're getting enough benefit, and they have tight enough deadlines where those things don't get fixed. So they're not really getting the benefits of reporting. They're not getting the benefits of analysis in terms of coming off their build servers. So really, developers may have insights locally to their machine because through their IDE they may have tools installed that give them some insights, but the overall team doesn't have any insight. And this drives to what we term as a pilot adoption. So governance is good. Understanding where the project is that you're actually supporting. Is it a cold start? Is it a new project? Do you have it in a gate or a particular SDL state, or is it being worked? Time box activities, analysis of value, taking a look at how much time people spend doing stuff. Is it all done on their machines? Because those are real opportunities with very small changes to increase the productivity of the organization as a whole. And then, of course, like all things, if we're talking culture, you need the organic support. So individual contributors, developers, testers, your security folks, and management. I say it best works with upper management support and interest of the engineers that are supporting your organization. Final piece is, I think I mentioned earlier, we say anything that reduces human intervention is good. That goes back to DevOps is a lot about repeatability, precision, being able to capture what was actually done, report it out to log systems, and then report all the way up that it did occur, it occurred in the right order, services were up. A lot of those things, you just can't create that type of repeatability if they're manual services. And the final thing, I said evaluation, compliance, segregation of duties in the actual pilot. Well, that's for the team as well. You need to include cross-functional teams. Again, they should go through training because that allows you to capture a much richer set of vocabulary and requirements for all the groups that support delivery of software for your organization. So from our perspective, here's the 5 Ps. If you've ever been, I don't know if anybody went through TQM as a young person, but proper planning prevents poor performance. It's a true statement, for many years. When you take a look at this chart, this is a view of how we suggest to construct teams to help you in your DevOps journey. So we take the top level components, the integration, testing, monitoring, the delivery pieces. You're using organic team members. You'd like to have an expert resource in that particular area. So what are the top services that are provided, and that leads you to the top tools. And we like to do it, you can do it either way, but obviously you want to get it right for your organization, which is unique, has a unique culture. You're delivering on a set of services that is very unique to your organization. So we like to go from service to tool. But you still need an expert resource that's worked in continuous integration on the build side, continuous testing. So they need to understand, both API and various tools and techniques to implement testing across the project. Same with monitoring, same with delivery. You need an architectural resource, someone from the architects, from your architecture or your organizational architects to support it because, again, they can spread the word and also support you and you can get, certainly you can get guidance in terms of vocabulary, and it's still an opportunity to share information throughout the organization, and of course management support. So each one of these, we'd suggest the best case is that you can have teams, integrated teams, being able to work each one of these issues from a management perspective. This leads us to, as I was talking about before, for the integration, testing, monitoring, delivery, there's a set of services that are provided. So you want to normalize the vocabulary, and it's not complex, but you do want to have it unique for your organization. So we say service and outcomes. So this is the first thing. So continuous integration, that's a service. Source code management, that's a service. A build is a service. Package management, test automation, test frameworks, reporting, notification, collaboration, all these things. And again, I apologize, it's a lot of stuff there, but I wanted to give you an idea for each of these categories that we've actually put together. These are possible things that overlap just based on the daily work that people do, right? But you want the actual groups, as I said, to establish, what is continuous integration, and then what are the outcomes. So, and if you map this to a tool, I want tool stack or tool chain orchestration out of continuous integration. I want a project history, and there may be, project management type things. Take another example in terms of, let's see, data management. So there's, what are the outcomes from data management that you actually have to do in each one of these categories: integration, testing, monitoring, or delivery. So is there a data generation piece? On the testing and on the integration side, there may be. On the monitoring piece, there isn't. On the delivery side, there isn't. Is it a spreadsheet? Do you actually know the types of access mechanisms? Is it SQL or no SQL? So again, this allows you to map outcomes that need to be addressed when you finally start selecting your tools and organizing the architecture. So focus on the outcomes, organize by the tenants: integration, testing, monitoring, and delivery, and build that common vocabulary. And that leads to, now you can actually do paper architecture. So what I say is, so what's a paper architecture? It's that whole idea that you converted that service vocabulary to a set of actors and services, right? So this is a continuation, this is continuous testing. And again, the perspective may be an automation engineer. What tools do they actually use? What do they need to support their environment from a whole? So there, you can look at this, in the center of it is that orchestration tool. So it could be Team Foundation Server, it could be Jenkins, as I said before, it could be Team City, could be Bamboo, could be Travis. We don't really care. We just want to know that there's a mapping, that this person needs this type of tool, these are definite options, or if you're doing this for your organization, you can put in the options that are currently used. And this is one of the examples that we have from working with another of our clients. So they had both Team Foundation Server and Jenkins in there all at once. So again, using a paper architecture, you're able to test outcomes, eliminate duplicate products, like you could decide to go to one. And so Jenkins is free, but there's still a maintenance component, and it's certainly different to administer than Team Foundation Server, and that build engineer that may be administrating Team Foundation Server now has to administer Jenkins. So there's there are lots of good reasons to use these techniques to simplify the sort of the needs and the wants, understand the actors, and be able to put that architecture together without committing to a particular product or vendor. So from the paper architecture, now we're able to actually move to work streams. And this is the act of really doing the work. So you've been able to eliminate stuff, but you still have to plan and organize how you're going to tell people to reconfigure or what they need to do. So there's standard sort of business process here. This is a COBIT, it's either COBIT 5 or 6 standard that we actually use, but it's really plan and organize. So now that you know what you're going to do, you've got the planning, you can actually organize what needs to happen. If you're buying new tools or investing, you need to actually build in the acquire and implement piece. Then there's the actual delivery, sort of standing it up, and then monitoring and evaluating how it's doing for the organization. Now each of these you may have, as I said, there can be a lot of duplication based on tools and needs, so you can combine some of these work streams, and you can you can assign teams or consultancies, or again you can combine these related work streams into one, and set aside the team that would actually be responsible for building these plans. You gain a lot of flexibility if you think about when you're putting these things together, because as I said, it's a very low cost. It's very low cost until you start doing the implementation. The planning piece, the understanding the requirements, the combining or defining your own vocabulary, those things are things that people are really interested in doing. We've had a number of clients where people are dying to get on the teams because they see the value of DevOps, again, both for their organization as well as their careers. But the work stream is the final place where the rubber hits the road and the implementation begins. So general takeaways. So we went through sort of our view of the tenants. We went through techniques that we use to get to workable delivery components that can be managed, and now again the set of takeaways that we want to leave with you. So DevOps is definitely not a fad. For our purposes, and to get it right, I mean, you can do quick projects and get stuff in, but what happens is they don't necessarily deliver sustainable solutions. And what we normally find is, as opposed to addressing the cultural issues or fixing the tool that was installed to integrate properly with the other tools that it needs to work with, we find organizations say, oh, that tool wasn't that good. We're moving to this one because this one is really great. And the reality is, again, it's just a tool. And my dad used to say, a fool with a tool is still a fool. So you still got, it's not the tool. It's really understanding what the actual need is and making sure the implementation is correct. So again, I can't, I really want to focus this, looking at outcomes and architectures, doing the paper exercises is much better to delivering a sustainable solution than jumping in, based on a tool that a consultant that you bring into your company says, hey, this is what I used, and you say, oh, great, let's use it. It's really not a great approach for an organization. Third, be inclusive. Someone needs to understand governance issues, security, partner requirements, testing. So those teams, even though you may not initially understand or want to involve, one person representing each of those components because you're not sure, what does a governance person understand about continuous integration? it goes back to shift left. So the governance person may say, hey, you know, is there a way to test some of these governance requirements that we have? Security is another example. You know, can we do static analysis on the OWASP top 10 or SANS top 25? And of course the answer is yes. And why aren't you doing it? Right? But a lot of times you don't actually have the people in the room to ask those right questions to be able to flesh out the architecture. You need a top-down and bottom-up approach. As I said, you need management support. Management has to be able to take your vocabulary and explain this to the business. And people who are doing the work have to be interested. The bottom up, you have to have your individual contributors who are really interested in this stuff. Today, there's not a problem on either side. There's so much information out there about DevOps, the value of it. You know, Amazon being able to, you know, deliver whatever 11.5 releases per minute. Other people. Other big organizations wondering why, you know, their quarterly release cycle is such a problem. So, you know, there's great interest in this because there's great business value, there's great technical value. Use experts. Again, experts help you eliminate the common mistakes. You don't, you know, again, you want the commitment and the culture to be internal, but you don't, you know, you don't want to make mistakes, leave configurations that that might put at risk your data, intellectual property, or you know, other issues. So that's the reason why you should include experts. Do projects in the correct order. As I said, DevOps, you can run into situations where you've implemented something, you're building a lot, but you don't have a good branch merge strategy, you're not doing testing, so really what you start getting are just hundreds of build failures. We had clients who said, hey, I want this build machine to build, you know, I want it to build every minute, you know, and so what they got is, you know, a big red ball in their Jenkins dashboard because the environment and the software was not ready to build successfully. So projects in the correct order is important, and then the final sort of, you know, my dad's lesson back to me is don't boil the ocean. There are lots of places to remove human action or human interaction. There are lots of improvement opportunities for all of us. Go for the simple wins. Use the techniques that we are describing because they'll help you actually achieve those simple wins earlier. And they'll sort of level or normalize expectations about what can be done. So that's it for the presentation. We do have a special offer for DevOps assessments. What does it include? So we will help you sort of build that vocabulary, do the paper architecture, get you all the way through the actual work streams. If you're happy with us, certainly you can use us going forward beyond that. But this is limited to the first 3 webinar participants, and it includes up to 2 weeks of work. And that's why I said you can do these things fairly quickly. If you know, again, once you establish the teams. List price $15K, special offer less than 10, $9.99, $5. Sounds like a wonderful deal. I think we're ready for questions.
All right, I think we have a couple minutes. We can take a few questions. I have one that rolled in from someone named Stephen C. His question is, he deals with regulations preventing developers from making changes to production. So how would DevOps and pipelines support him?
Right. So so Stephen, a lot of organizations, large organizations, face that issue. And really, what it is, DevOps is not allowing. You don't have to allow the developers to actually do the release. What you need to do is sort of think about it as a pipeline with segments. And the continuous integration segment, where developers are actually checking in source code, building off their machines using continuous integration servers to actually build and report back to them about whether that release is built successfully, then that going into a testing environment and actually being tested. Those things can be segments of the pipe. And then as you get to development, they're based on regulation, the next set of activities based on role might not be executed by the developer. The developer has already done their piece. They've delivered software that builds, it tests successfully, it's a release candidate. Now it's time for the operational people to take those artifacts. They're not rebuilding, but the operations is basically taking those artifacts and then they're actually delivering those artifacts within their own pipeline segment. So it's very much possible to implement these things without having the developer do the actual final delivery into production.
Okay, it looks like we have time for one more question. This question is from Ben P. He says he hired build masters to support his DevOps practices, but the time it takes to deliver a feature has not dropped much. Have you seen this, and why does it happen?
Yeah, so as I said, what happens, that's usually a cultural issue, because the build engineer, for some reason, they'll have the build engineer responsible for the success of the merge and the build. And so the problem is the build engineer usually doesn't understand the feature or the source code or how changes that may be affecting the same file should be merged. It's really the responsibility of, let's say, the development lead or the architect to make the correct merge. And this is, larger teams, multiple people possibly having to touch the same file, making changes to that same file. What changes do you accept? Do you accept all of them? And so that's what normally happens. That's one of the reasons that the build master is unfairly requested to either make merge decisions or to go hunt down the developers because a build broke and no one's fixing it. So I say those things are really related to culture, and again, one of the reasons why our technique actually brings these different groups together so there can be cultural changes as well.
All right. Well, due to time, that wraps up today's webinar questions. Will, I will send it off to you for final farewell.
Well, I appreciate everybody coming. I hope you're as excited as these techniques as we are. As I said, we've been using these techniques for a while with great success, and we look forward to helping your organization achieve the same success.
All right, that concludes today's webinar. Thank you for joining us.